It's Vector Podcast, and here I have Alessandro Benedetti with me. His second time on the podcast, actually, and exactly about same place. We recorded 2 years ago. Do you remember on Berlin Buzzwords?
Yeah, we were here 2 years ago, 2022. Time flies.
It was, by the way, a lot noisier, if you remember, than now. But
it was closing day. There were like people assembling and disassembling stuff.
But I think it's almost end of day as well here, first day of the conference. And I wanted to chat with you. How do you like the conference so far?
So it's been so far like a great conference. We've been seeing like many talks about large language model integration with search. So that's the biggest new trend. Vector-based search is still quite a strong topic. And in general, we start seeing also like evaluation and explainability discussions around like vector-based search or in general large language models. And my talk specifically was about hybrid search.
Hybrid search, yeah. So you work a lot on Solr, right? That's your kind of like playground, and that's where you integrate things. But also then I heard that like guys at Reddit are using the work that you've been doing also in Solr. So that's amazing. Tell me a bit more about what is hybrid search, right? How do you see it? What's the value? And basically maybe what are the challenges that you needed to solve and you still see related to hybrid search?
So the first point and the reason I decided to start working a little bit more in hybrid search and contributing reciprocal rank fusion to Solr is because of the limitations of vector-based search. So vector-based search, of course, introduces like the ability of closing the semantic gaps with like queries and documents with some limitations, right? So the explainability part, for example, is an aspect I care a lot. And it's just very difficult to explain vector-based search results.
Yeah,
we have high dimensionality, so many dimensions in the vectors. And humans are not really good in managing many dimensions. We live in a three-dimensional world, and it's even difficult for us to understand like four-dimensional like vector spaces.
Yeah.
Then we have like many elements in those vectors. So each feature in the vector doesn't have like a meaning for the human. So you have like 768 dimensions in your vectors, and there's no a single dimension that means something semantic. So it's just the output of some machine learning model, but we can interpret like what it is. And we can interpret what would happen if that feature goes higher or lower. I mean, does a higher value for that feature means higher relevance or not? You can't really do that with vector-based search. So these kind of problems start to have like an impact, right? So you have like your clients using vector-based search, they are happy and then they are not, and they want to explain, for example, some queries and what happens. And another limitation is keyword-based matching. So by default, vector-based search try to solve the vocabulary mismatch problem. So you have terms in your vocabulary that's different from the vocabulary used for queries. At the same time, users are used to have keyword matching documents in the response. So when you don't provide keyword matching document in the response, there's going to be like problems and questions.
Why do I see this?
And why I don't see, for example, this title with this keyword. So with hybrid search, the idea is to mitigate those problems. So mix up different query result sets, potentially like vector-based search results and traditional keyword-based search results, get back one result set that try to combine both worlds.
Interesting. And if we kind of step forward from this, let's say we deployed hybrid search, right? So now it basically takes some similar documents from keyword hits and then another one from vector. You still get those documents that do not have keyword matches, right, from the vector. space. Do you know, or maybe you have employed some ways of explaining to the user why they see them?
So that's an interesting point. Actually, I had a discussion recently about how can we explain better like vector-based search. So we mentioned already all the problems with explainability, but what can we do better? So there are other approaches than just pure dense vector-based search, such as learned sparse retrieval, for example, where you learn query or document expansion term candidates based on learned models. So based on the probability, you will expand your queries with additional terms.
Yeah.
So that's a little bit more explainable because at least you get back from the machine learning model alternative terms for the queries and the document. It's still a first layer of explainability. So you have some lexical like additional concepts, so it's easier to understand. Still, you have a probability assigned to that term. So if it goes wrong, you may end up with unreasonable terms. So not perfect, a little bit better, maybe a little bit more explainable. And then there are approaches such Colbert, where you encode your sentence, not just one vector, but to a sequence of vectors. So multiple vectors, one per pair potential. And you do the same for your documents. And then you basically return results based on the similarity between not just a single query vector and the document vector, but multiple query vectors. So each query vector, which is going to be probably a term with the terms in the document. So you may be able to highlight the terms in the document that are close to the terms in the query. Also, in this case, of course, it's just a first layer explainability, because then if this goes wrong, of course, again, you have sequences of vectors. So you can get like a sort of heat map of what query terms matches like more or less the document ones, but still not perfect.
Yeah, sure. Of course, it's kind of like maybe experimentation that is required, right? What works for you? What is the end product? But maybe one question is, for me as a user, right? Let's say I'm using Solr and you offer hybrid search now. Are you already offering, or will you consider at some point offering the capability to ingrain what you just said into, let's say, highlighter in Solr that will actually build me the snippet regardless of the source of that document, whether it's keyword or vector?
That's a very interesting question, because there are, in my opinion, two layers of explainability. Explainability for engineers, so who needs to work on the engine and change the ranking, change the matching, and users explainability. So a user that just want to know why, for example, a document is there. And for user explainability, actually, my company, we designed and developed an highlighter we call the neural highlighter that takes in input a large language model, and in the response, we'll highlight the snippet for each resulting document, not based on lexical match, but based on a question answering system powered by large language model. So in this way, you will be able to highlight part of the original document that are semantically close to the
interesting.
query.
Can you say the name again? What was the name?
It's called the neural highlighter.
Neural highlighter. So it's your proprietary product?
Right now, yes.
Developed in C's, right?
Yes. Right now, yes. We may contribute it open source in the future. I don't know. Right now is one of our products. So
But I mean, it's a feature that is it offered as a standalone component?
It's a plugin. It's a plugin. So
it's a plugin to Solr.
It's a plugin to Solr.
That's the value prop as well, right? It doesn't always need to be open.
No,
it's something I can plug in and
exactly. It takes in input the large language model inference points. So you can
so that will help to explain results to the users, right? And you also mentioned, right, it's thanks for doing this distinction, making this distinction, that there is also explainability for the engineers that is also important. So can you a bit explain what you mean? Explainability for the engineers, because I care about it a lot, of course. And when I used to be an engineer full time, I need to know how to do it, how to tweak something, but also can I explain to myself that what I tweaked is actually the right thing, right? So, kind of the process of engineering the changes.
So in Solr, for example, there is a debug component that gives you the ability to the engineer to expand the response with the information about how the score was calculated. So in Solr, when you have a query and you have a result, a score is calculated for that result for that query, and the score will impact the ranking. So descending order, basically, right, from the highest score to the lowest. And normally the score is explained showing why you get that mathematical calculation from the term frequencies,
Yeah.
the length of the document field, the average length of the field, the document frequency, how rare a term was, for example, and so on and so forth. So long mathematical expressions that are readable to the user, and you can understand, okay, I was aiming for this field to impact the score. Let's see if that field really impacted the score. With vector-based search, right now, the only explainability you get from an engineering perspective is literally within the top K. So this document was within a top K with a cosine similarity between the query vector and the document vector. That's not really helpful. It's just confirming what you know already, right? I mean, it's in the top K, it was returned. So one of the ideas I was thinking on, because I'm actually quite far from the implementation, is to explain the reason a document is in the result set, showing examples of, so large language models used to return embeddings were fine-tuned on sentence similarity. So this means there were pair of sentences with similar meaning and pair of sentences with dissimilar meaning in a way that to learn how to encode the semantics. So I think it could be very interesting if to explain the reason a document is being returned because of vector search, you show like a snippet saying because there is this similar pairs of sentences and this dissimilar set of sentences in the way that then potentially the engineer can go back and realize, okay, let's take a look to the original training data, for example. Did I cover this example well, or maybe they are wrong? So I see like, oh, these two sentences are shown as similar, but they are not. So this could help potentially. You know, it's just an idea, no study yet.
Yeah, that's very interesting because, as you said, it's very limiting today to just know that geometric search happened and these are the results.
Yeah,
so
exactly.
that's amazing. I mean, it's really interesting that with this work, you are not really just taking something and applying to implementation, right? Like, I mean, implementing a plugin, but you actually go into the space of exploring things because it's not like everything is done, right? And maybe in some companies it has been done, but they're not open sourcing, right? And so you need to do the search of the solution. That's very interesting. So in terms of functionality today, hybrid search is already available in Solr, right? Has it been already released in which version?
Yeah, so there are different ways hybrid search can be performed in Solr. So right now with Solr 9.6, there are ways of combining results from lexical search and vector-based search, and then re-rank them, for example, using learning to rank. So you give like different weights to different factors. So for example, the vector-based score or the traditional score.
Yeah.
What is coming next, which was the topic of my talk, is Reciprocal Rank Fusion. So that's coming with Solr 9.7. So I guess in a couple of months, we are going to release it.
Nice.
And that is a way of having hybrid search that is independent on the score and just based on the ranking of the results. So you mix the different ranked lists. There can be two, maybe more. It's more supported, not just two. And then you combine them based on the position of the documents in the different ranked lists. The higher the position in the ranking, the best the probability that that document is going to end up in a higher final result set.
Actually, when I was, maybe you can help me understand this, but when we were trying Reciprocal Rank Fusion with another search engine, you know, we actually found implementation, so we could kind of plug it in Python code very quickly. But then when we looked at the code, one of my engineers said, this looks like round robin algorithm, essentially. There is nothing like particularly peculiar about it or tunable about it, which probably is not true, but I'm not sure. What's your take on this? So it felt like you have two lists and you basically just take the starting from the top, you take like in order, you know, these documents and you combine a blended list, right? But if you wanted to pay attention to some signals from these documents, you know, based on their features, or maybe you wanted to introduce a logic on top of this, right? So you want to say, let's say in the context of geographic search, I want to find in top 3 results, I want to see a super popular POI, and I know what popular means. Okay. Another second result could be, I don't know, the closest one, or maybe vice versa, depends, and so on and so forth. So I have some kind of rules in bed, and then maybe it stops becoming RRF already, right? But I still taking a step backwards. Did I explain it right, or are there some parameters in RRF that I could kind of be tuning a bit to have the different outcome?
There's not much to tune, to be honest. So you got it right. It's not only round robin, because what you do is basically you give a new score to the documents that's based on all the rankings of that document in the result lists. So it's not like interleaving where, for example, you go with one document, you pick from one ranked list, and then to the other ranked list, you pick another, and then you choose which one should I go next. It's more about like, let's see this document, how many times it appears in the ranked list and where it appears in the ranked list, and let's build this new score.
Oh, I see.
So the more you are in the top positions, the more likely you end up in the top position of the final result list. Given that, you're absolutely right that if you want to build like more advanced ranking systems, potentially like with different phases, different steps, it makes complete sense to maybe build your original candidate sets with Reciprocal Rank Fusion, and then you re-rank, for example, using learning to rank and many features, where you can have like, again, maybe the vector distance as one feature, the similarity with one field from an lexical perspective, popularity, geographical distance, and many other features. And then you apply learning to rank, for example, so you train a machine learning model to identify these weights. It makes perfect sense, in my opinion. I believe Reciprocal Rank Fusion, and in general, like, let's call them simple approaches with hybrid search, because if you take a look to the algorithm of Reciprocal Rank Fusion, it's not that complex. It's actually even an old algorithm from 2009. But this opened the doors, in my opinion, to build your original candidate set, and then potentially like you re-rank a top K. Which is not random. A top K, which has already some reason to be there.
And of course, like in any case, goes without saying that we do need to have some method of combining these completely disparate spaces of scores, right, into one. And that could be actually even like different search engines operating on keyword level, because they output different scores, right? So, or maybe even potentially, I'm thinking a separate shards of your data that also have their own idea, right? Local idea. So could be incomparable, right? Awesome. We also, not related to this, completely different topic, like there was also a keynote today about sort of what open source means, right? And without, of course, criticizing, but some companies were mentioned in this context where they claim that the LLMs are open source, but when you look at the licenses, they are restrictive. They actually do not allow you to use them independently, right? And kind of go and serve your customers. But you also just mentioned before we started recording is that there are also cases where the model can be open source, and it's kind of like more or less abiding the principles of open source spirit, but then but then the data that it was trained on is not open source, or the methods that were applied to the data are not open source, right? So to me, it sounds so important to keep kind of declaring what open source is, what are the principles, right? And maybe this keynote also shed some light, but you also, it seems like this topic is also very close to you, and you are in the open source contributing a lot. You are the committer. Like, can you share your vision on what is open source? What are the implications for how this field should be developing?
I think it's a huge problem, especially because nowadays open washing, which is like the practice of associating openness to something that potentially is not really fully open, is happening a lot, because open source is cool. Open source show like a good ethic. So you're the good guys if you do open source. So as you said, we are not going to make names of companies or associations that claim, for example, their large language model were open source, but large language models are complex systems. So the output, the final like weights of the neural networks is just one little part of the entire picture. Those large language models are normally pre-trained on huge quantities of data with a pre-training algorithm. So the pre-training data and the pre-training code, is it open? Is it not? I mean, many times it's not. Not only not, it's not open, it's not even known what kind of data. It's just generic internet scale data. What about the fine tuning then? So once you get the pre-training, which is the unsupervised part where you just explore the web, let's put it simple, then you want to fine tune for specific tasks like sentence similarity or instruction following, or I don't know, summarization, any kind of task you want to use the large language model. And to do that, normally use an additional training data set that is specifically designed for that fine-tuning task. And again, is that open? So do you communicate and did you make it available? And the code for fine-tuning, do you make it available? The output of the pre-training, do you make it available separately from the output of the fine-tuning? The documentation, any paper that explains what you've done, why you've done that? So I've read like an interesting paper that I guess we can share like as a comment from a university that were like comparing all these aspects of large language models and how famous like open source large language models actually behaved on each of these columns, and would be surprising how small percentage of these like big players are actually open sourcing everything. So it's not just the license that, as you said correctly, sometimes is limiting, but literally like the components shared, sometimes it's just the final output. Which is it helpful? I mean, in open source, you want to cooperate, you want to improve the code. Like in normal code, you have access to everything and you can like improve, you can help the community. If you just access the ways, you can use it, but can you, for example, improve it? Can you understand if it's fair? If the data used was fair, biased? It's really difficult.
And so where do you think these discussions should start, or maybe it's ongoing? Are you part of some discussion? And how does it impact business and maybe research, right? Because there are different sides of this coin. Many of these things emerge in the academia space, but then they move to create value on the business side. But it could also be vice versa. So what do you think? How should we address this?
So I know that the open source initiative, which is a group of people that basically direct the open source manifesto and try to basically think to ways of defining open source, is they are working on a definition of open source for AI models. So we are going to see, hopefully soon enough, a definition of what it means for a model to be considered open source. And that is going to be great, because at that point, it's not a matter of like, oh, I believe it's open, and I claim it's open. It's just, or it's open or it's not. And everything is covered by a license that is going to be or open or not. And in terms of like impollination between like the academia and in the industry, I think probably that's the most, I mean, this period is so important to see like cross-pollination, because there are like many models that, for example, are designed and contributed by the academia that must then be used by organizations and the other way around, because of course there are like a lot of money involved in training and pre-training and fine-tuning large language models. So many, I mean, only few actually organizations are able to do that. So they should try, I mean, ideally to make it as open as possible in a way that then universities can focus on small components and potentially help improving them. Because I mean, you know, pre-training and internet scale is incredibly expensive from energy perspective, especially. So I hope, you know, we reach a point where everything is open enough for also smaller organization and academia organization to help.
Yeah, it's very interesting because there is always going to be this kind of play between, okay, this big company has all the servers, they need to train the model,
Exactly.
so they can also decide how they will do it and not kind of disclose. But then maybe the question that we need to be disputing and sort of discussing is that they still don't have all the data to train on, right? Potentially. Like there have been some cases mentioned in the keynote, you know, when some company, we will not name the company, goes and trains it on some articles of a famous publishing house, right? And now that publishing house is unhappy because they say you took our articles without us knowing this. Now it kind of evokes these questions. Okay, when I was reading this article, there was probably some license which said you can do this, but not this. Maybe there is something hidden, right? But only now we started discussing these things, right? And that's very interesting topic. But do you think that, you know, when the companies will be, let's say, they have open sourced a model and they have checked everything on that manifesto or on that contract, do you think that there will be still a need for some maybe tooling or some process to kind of continuously maintain the status of this model as open source? Because it may well happen that, you know, either the company or research institute, they go and accidentally use some data that doesn't anymore comply with this contract, right? First of all, without LLMs, do you think such thing exists, let's say for Apache Solr or Lucene, that no one will find a library that is not the license that it has to be, plugs it in, and we do a release of Lucene or Solr? I think there is some checker, right?
Yeah. So this applies to a certain extent to code as well, right? So you are a contributor. When you sign basically the, let's say, contract with the Apache Solr Foundation, you are sure that any kind of contribution you do is your own. So that's not being copied, for example, that was not copyrighted, and this sort of thing.
So it's genuinely created by you.
It's genuinely created by you.
Yeah.
So to a certain extent, that would be a similar thing to potentially add some training data. I think probably it's a little bit less likely that, like in an existing large language model, for example, someone would contribute, I don't know, more data. I mean, it's more likely that maybe you change a little bit the code, for example, responsible of fine-tuning and these sort of things. But still, I think there would be this layer of responsibility that would weigh on the shoulders of the contributors, because of course you can't have control on the single individuals, and you need to have like this sort of layer where the no-profit / open source project protects itself from.
Because I can imagine that, again, it's probably putting it to extremes, but there could be eventually some tooling where you take the model and you introspect its behavior and you can make a guess on which data it was trained, potentially, or at least find some similarities with how it produces. I mean, there've been some attacks, so to say, right? So you can actually probe the model and see what it outputs, right? You can even break some models sometimes.
That's true.
But that's more like on the hacker side or the bad hacker side. But I mean, there probably will be tooling. Do you think it's possible that there will be tooling kind of checking the model and making some hypothesis? And as you said, once caught, that organization will kind of lose its trust, right? So obviously everyone wants to be kind of accountable and so on. But then there could be a flip side of that you can kind of accidentally assume that they did it, but that's not true, right? Now that becomes a very hard debate, right?
So it's an area which I think deserves exploration and study.
Yeah.
And I believe that's, you know, being accountable of like the data you use and disclosing it, of course, is the first step. But then, also validating that companies said the truth, for example, I think is going to be important. As you said, like, to build trust and to make sure that what you disclaim is actually what happens.
Yeah.
Because we never know.
Yes, it's very interesting. Was there some other topic you wanted to cover? I mean, are you also working on RAG or anything of that, or evaluating the LLM-based search?
We are working on many different integrations with large language models. Retrieval augmented generation is one of it. Natural language parsing, for example, is another. So moving from natural language to structured queries.
Yeah.
Probably the last thing we can discuss, the last topic we can discuss is prompt engineering.
Yeah.
Briefly, because
Yes.
is this naming convention is something that really hurts me, because it's not engineering at all, in my opinion, because you're just attempting to communicate with something and you don't know what to expect.
Yes.
Because I've seen tools today with people saying, you write this prompt and you hope you get this response.
Yeah.
You type this prompt and you ask, please give me the response, which is, to me, something that is, not scientific at all.
Hope
right?
is not strategy.
It's not strategy. It's not science. You can't just be something and hope.
Yeah, it's
you
not
get back a response.
repeatable. Yeah.
So there's, in my opinion, just to keep it short, a big margin of improvement there to interact with large language model in a more programmatic way.
Yeah.
I want to specify a task with rules and get back a response that satisfies those rules. If I want to select an item from a list, I want to select an item from the list. I want the large language model to be able to just select the item from the list and not 80% of the time select the item of the list, and 20% of the time select the item and give me an explanation that I didn't want. I just wanted the item from the list.
Yeah.
And right now I've seen, and we will see at the conference, because I've seen in the agenda, there are like many talks about trying to solve this problem. But right now, what I've seen as like possible solution is just like you post-validate the response and you go back. Like, okay, I asked for a specific JSON in the response. There are mistakes. It's like, it's not a parsable JSON. I go back to the large language model and say, this is not a parsable JSON. Can you fix it? And again, and again, and again, which is not really something you want to go to production. So in short, in my opinion, like using large language models programmatically right now is cool for proof of concepts, but would I bring to production like out of the box like these sort of approaches? I won't, because I would, I want to bring something that is deterministic. It does what I want to do 100% of the times, and not sometimes. And I don't want to hope it's responsive well. I want to make it work. So
but it's also like, I see, it's very interesting topic, by the way, but I also see some level of contradiction that like between non-deterministic and hallucinating model, essentially hallucinating by design because it keeps predicting the terms, right? And some level of determinism, as you just explained, right? But I guess at the same time, someone might say that our life is not that deterministic, many moving parts, and we still find a way to, I don't know, leave it and then build something, right?
Build
something that moves.
I think, it's the first, anyway, we are experiencing, in my opinion, a first step in this new world of AI big models. So I think it's fair. They were born to autocomplete text, to generate text. And now we are trying to use them to do tasks.
Yes.
Which is okay. We as humans use language to do tasks.
Yeah.
So I just guess, and then we end up with programming computers, right? So let's wait till large language models will be programmable.
Yeah. I mean, it does remind a bit, I haven't explored it, but to mention DSpy, the package, probably you heard about it, right? Which replaces the prompt engineering with more programmable sort of way of doing it. I still don't know how it works, but I know that some of the engineers in my team applied it quite successfully to generate some synthetic queries. So that was very interesting. Have you played with it? Do you know?
So my team, we've been playing with it for one of the proof of concepts for doing natural language query parsing, so structured Solr queries. And I think it's a nice first step. Still is giving you like an indirection between the prompt and the way to write a prompt. So you have like classes that mimic the programming language, but then ends up as prompts.
Yeah,
still,
I see.
You are not as sure that you will get
what
you want.
Exactly.
but it's a first attempt.
Yeah, yeah.
So I think it's okay. I mean, we will improve on that.
It
So
feels maybe like first baby step in a way
Exactly.
that
it's not a
towards
solution.
the
It's
state
not a
that you mentioned. Yeah, that's
not
very
a complete solution, but
yeah.
it's great.
So what's next that you're working on that you want to disclose?
Yeah. So first of all, I want to bring and merge the hybrid search reciprocal rank fusion to Solr, which is coming in 9.7. So I'm very close to the merge.
Awesome.
For that, we got some funding from the European Union to work on Solr. So that's like very
Awesome.
positive thing.
Congratulations.
So we are going to be able to contribute more vector-based search capabilities, better integrations with learning to rank, better integration with like inference endpoints to make it a little bit more transparent.
Fantastic.
And still in the work like multi-valued support for vector-based search in Solr. And there are like some features in Lucene to speed up and improve, optimize vector-based search that are not yet in Solr, and that's among my top priorities. So this in short
This is
what we're
fantastic.
doing.
This is fantastic, and of course, it's all open source, and
Yes.
you know,
it'll be all open source.
yeah, and then like anyone can join, but maybe we can also make a call out and say that
Absolutely.
you know,
I mean, everyone that wants to contribute, you know, the more the merrier. So,
yeah, I actually enjoy, like, even though I don't do Solr or Lucene today, I am still reading the mailing lists. And for the most part, I'm reading the Lucene one. So sometimes I see your discussion as well, and where you say, actually, by the way, I'm working on this hybrid search. I did this and this, so maybe it will influence you. And I also love the culture where you do not really enforce or impose your solution. You just say, just for you to know, maybe it will be useful. And someone says, yeah, awesome. I especially love that discussion. I forgot the particular topic, but I remember that it's a recent one. And,
it's a recent
exactly. So keep up your great work, Alessandro. It's always a pleasure to talk to you. And
my pleasure.
It looks like it's a tradition that we started meeting in the same corner of the Berlin Buzzwords.
It's biennial.
Yeah.
So every 2 years we'll meet here.
Yeah, Berlin is a beautiful city. So fantastic. Thank you so much, Alessandro, and enjoy the rest of the conference.
Thank you.
Thank you.
Thank you.